Coplanarity of two lines. If two lines vector r equals vector a1 plus lambda vector b1, vector r equals vector a2 plus mu vector b2 are coplanar, then their common plane must be parallel to each of the vectors vector a2 minus vector a1, vector b1, vector b2. That is, these three vectors must be coplanar. Therefore, dot product of vector a2 minus vector a1 and cross product of vector b1 and vector b2 equals 0. In Cartesian form, if the lines are x minus x1 by a1 equals y minus y1 by b1 equals z minus z1 by c1 and x minus x2 by a2 equals y minus y2 by b2 equals z minus z2 by c2, then the equation of the plane containing lines is determinant row-wise. First row, x minus x1, y minus y1, z minus z1. Second row, a1, b1, c1. Third row, a2, b2, c2 equals 0. Angle between two planes. The angle between two planes is defined as the angle between their normals. Let theta be the angle between two planes. Dot product of vector r and vector n1 equals d1 and dot product of vector r and vector n2 equals d2. Then theta is the angle between two vectors n1 and n2. Cos theta equals modulus of dot product of vector n1 and vector n2 divided by modulus of vector n1 into modulus of vector n2. In Cartesian form, if theta be the angle between two planes, a1x plus b1y plus c1z plus d1 equals 0 and a2x plus b2y plus c2z plus d2 equals 0. So, cos theta equals modulus of a1a2 plus b1b2 plus c1c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Distance of a point from a plane. In vector form, length of perpendicular from a position vector A to plane dot product of vector r and vector n equals d is given by, in Cartesian form, the length of perpendicular from a point P x1, y1, z1 to the plane ax plus by plus cz equals d is given by. Example. Find the distance of a point 4, 2, minus 1 from the plane. Solution. Given vector A equals 4 cap I plus 2 cap j minus cap k. Vector n equals 3 cap I minus 4 cap j plus cap k. And d equals 10. The distance of the point 4, 2, minus 1 from the plane is equal to modulus of 12 minus 8 minus 1 minus 10 by modulus of square root of 9 plus 16 plus 1 equals 7 by square root of 26. Angle between a line and a plane. The angle between a line and a plane is the complement of the angle between the line and normal to the plane. In vector form, if the equation of the line is vector r equals vector a plus lambda vector b, and the equation of the plane is dot product of vector r plus vector n equals to d, then the angle theta between the line and the normal to the plane is cos theta. So the angle pi between the line and the plane is given by 90 minus theta, that is, sin 90 minus theta equals cos theta. And did you know Leonhard Euler was a Swiss mathematician and physicist, and he did great contribution in three-dimensional shapes and in their analysis. He made huge contributions to a wide range of mathematics and physics, including analytic geometry, trigonometry, geometric calculus, and number theory. Summary. Let us summarize what we have learned. Direction cosine of a line is defined as the cosines of the angles made by the line with the positive direction of the axes. Three numbers which are proportional to the direction cosines of a line are called the direction ratios of the line. If L, M, N are direction cosine of a straight line, then the equation is called a vector equation of the line L passing through a given point and parallel to a given vector V. In Cartesian form, if vectors A, B and R be the position vectors of A, x1, y1, z1, B, x2, y2, z2 and P, x, y, z respectively on line L, then the vector equation of the line L is vector R equals vector A plus lambda vector B minus vector A. Lambda belongs to real numbers. The Cartesian equation of the line is x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. If A1, B1, C1 and A2, B2, C2 be the direction ratios of a line, then the acute angle theta between the two lines are. If the two skew lines are, then the shortest distance d between the lines is. In Cartesian form, the shortest distance between the line is. The distance between two parallel lines is. In vector form, the equation of the plane which is at distance d is where cap n is the unit vector normal to the plane. In Cartesian form, equation of the plane is where L, M, N be the direction cosines of cap n. Equation of a plane perpendicular to a given vector and passing through a given point is, in Cartesian form, where A, B and C are the direction ratios of the plane. Intercept form of the equation of a plane is, if the lines are, and then the equation of the plane containing lines is, if theta be the angle between two planes, and then theta can be written as length of perpendicular from a position vector A to plane is given by the angle phi between the line and the plane is